All right, everybody. Welcome back to our program applying the 7 steps of data analysis to produce a quantitative research study. William Bannon of Stats Whisper with you again. In the presentation today, we are going to review check 3 and check 4 of step 3, the checks of data integrity. These checks we're going to look at are missing data and measurement tools. Again, in the 7 steps of data analysis, we are right here at step 3, checks of data integrity. Now recall in our parallel between data analysis and data analysis, step 3 is both checks of integrity, right? So in our data analysis, we're doing checks of data integrity to make sure the data is appropriate for dating or the show, right? And data analysis, we're doing step 3 checks of data integrity, right, to make sure the data are appropriate for analysis. So again, like last week, let's consider what's the value of a study if the findings are incorrect, right? So to produce accurate findings, we must consider 4 areas where data integrity must be checked. Statistical power, test assumptions, that's 1 and 2, and then 3 and 4, which are missing data and measurement tools. And again, in order to be sound and credible, a quantitative study must thoroughly address checks of data integrity. So again, like last week, we're going to use sample study 1 to illustrate how to implement checks of data integrity, because sample study 1 uses a continuous dependent variable, which is more complex than study 2. And again, our research question for sample study 1, are people who live with dogs happier than people who live with cats? And again, there's our study map with our predictors on the left and our dependent variable happiness measured on the continuous 1 through 5 scale on the right. So we've seen all this last week, right? When we did checks of statistical power, check 1, and check 2, test assumptions. So now what we have left, what we'll look at today, check 3 and 4, missing data and measurement tools. All right, so what is missing data, right? So missing data, when you're doing your data analysis, is when you're in SPSS and you come to a cell and there's nothing in it, right? There's no data point for a study participant for a certain item, right? So if they ask gender and you're looking at that variable for study participant 1 and there's nothing in there because they didn't indicate it on the study survey, that's a missing data point, right? So one of the big questions we need to look at is, how can you indicate the level of challenge presented by missing data in a study, right? So in general, the more data that are missing, the bigger the challenge. Okay, now to assess the level of challenge presented due to missing data, you need to consider these 4 things. First, you must define missing data for that study. Second, you need to assess the amount of missing data. Third, you need to assess the pattern of the missing data. And lastly, you need to select a treatment for the missing data. Right? So when you define the missing data for a study, this might be surprising for some people, because you might just say missing data, you could define it as the proportion of items without valid responses, right? So if we had 100 items, meaning 100 questions, and 10 of them went unanswered for a certain study participant, 10 out of 100, that's 10%. So you could say, you could define missing data like that, and the missing data rate in that case would be 10% missing data. However, there's a problem. Not all variables in a study are created equal, okay? What we mean, for example, is that if we're missing complete data for our dependent variable, right? So suppose we're studying happiness, and a study participant provides no data for those items. That's more serious than if a study participant didn't answer the item for gender, right? So different variables have different levels of seriousness when the items are missing. So the missing data for a study might be defined as the proportion of missing data on one or a set of key variables, the more central and focused upon variables, right? So sample study 1, we might define missing data as the proportion of missing data missing from the independent and dependent variables, right? Missing data for the other variables, such as the covariate variables, are more easily handled, right? So suppose we have missing data for highest level of education. We could either create a category for other or unknown, right? Or we could use multiple imputation, which we'll review later, to estimate that missing data value. But it's not as alarming as if we had complete missing data for the independent or dependent variables. Now, let's suppose for study sample 1, we did define missing data as the proportion of data missing for the independent and dependent variables. Let's also suppose there's complete data for the independent variable. Therefore, the way we would define missing data for sample study 1 would be the percent of data missing for the 5-item happiness scale. Now here we go. This would be the study survey. This is how it would look with a missing data point for the happiness, 5-item happiness scale, okay? So imagine this is the study survey. It's a hard copy, a hard piece of paper, and someone's handed it to you for entry into SPSS, right? So the study participant circles their responses, right? So the first 4 items, happy, sad, good, and strong, all have circles. So those are valid responses from the study participant. However, the 5th one, glad, we've underlined those numbers, does not have a circle. In other words, the study participant did not select a response for the item glad. Now that becomes missing data, right? And specifically, a missing data point on the 5-item happiness scale. So one thing we need to look at after we've defined missing data as we've done are how much data are missing, right? And then there's a few dimensions of that, right? How much data are missing per item? What's the percentage of data missing for each individual study participant? And what percentage of study participants have missing data? So of 100, do 10 have missing data? Do 20? Do 30? Do 2? Right? We want to know. So to find out how much data are missing per item, that's perhaps the most simple. All we need to do is conduct a frequencies procedure. Here's the path for it, as we've done before, and it will be revealed. So suppose we did, as we state here, the frequencies procedure for the item feel happy. The first box produced would be this box, the statistics box. Right now, the line that reads valid, right here it says valid, and then going across it says 8. That's the number of study participants who have provided valid responses. And the line below that says missing, that's the number of study participants that have missing data for the item feel happy. So if you add them both together, that's the study sample size. 8 plus 6 is 14. So it's 14 study participants, 8 of whom have provided valid responses, and 6 of whom have missing data values. All right, so suppose we go into our data view of SPSS, and we're looking at the first 5 IDs for the 5-item happiness scale. Okay, so we could say these are the 5 items that make up the happiness scale. Feel happy, feel sad reversed, feel good, feel strong, and feel glad. Now there's only one missing data point, and that reflects the study survey, right? The feel glad item is missing for one person, right? ID number 2, study participant ID 2. So there's 5 items. So if they're missing 1 of 5, there's 80% complete data for ID 2, 20% missing data. Now the other study participants all have 5 responses, so they have 100% valid responses. Now, it's not very practical just to look up and down the 5-item happiness scale, right? So we need another method to identify the percentage, number and percentage of valid responses given. So on pages 149 through 152, you'll see there is a procedure in the textbook. There's a procedure called count occurrences of values within cases. So here we would put in the 5 items for the happiness scale. We would tell SPSS any value between 1 and 5 is a valid response, and then we would create a new variable, such as the last column right here, the variable name happiness num resp. So that's the number of responses, number of valid responses for the happiness 5-item scale. And you could see for all the IDs it adds up to 5 because they have complete responses, except ID 2, which adds up to 4 because ID 2 only provided 4 of 5 responses, right? So that's the number of valid responses per study participant. But recall, we want to know the percentage, right? What percentage of valid responses were given. So we carry on to pages 153 through 155. So you see the happiness num resp, right? Number of responses in the left-hand column here. To the right, we have happiness prop miss. So that's happiness, the proportion of missing data, actually the proportion of valid responses, right? So what we do here is we use the transform function, right, on pages 153 to 155 to divide the number of responses given for ID 2, that's 4, by the total number of items on the happiness scale. That's 5. So when we do that function, the new variable happiness prop miss is created. That's 0.80, which is 80%. So that variable is indicating that ID 2 provided 80% valid responses for the 5-item happiness scale. And the other participants have a 1.0, which is 100%, indicating they provided 100% of responses on the 5-item happiness scale. Now, if we run a frequency on that variable, the happiness prop miss, showing the proportion of valid responses, right, this is what we get. So in the statistics box for the output, right, for our frequency, you can see the yellow box here saying the frequency of 95 study participants, and on that same line to the left is 1.0, meaning 100%. 95 study participants provided 100% valid responses on the 5-item happiness scale. And then as we go up, the next one up is a frequency of 5, provided 0.8, which is 80%. So 5 study participants only provided 80%. Then going up, 3 study participants provided 60%. And on the top line, 2 study participants only provided 40% valid responses on the 5-item happiness scale. So there we have our proportion or percentage of valid responses on the happiness scale. Now, on pages 155 through 158 of the textbook, we use the recode, which we've used before, where we recode everybody who has a 1.0, which is 100%, in the happiness prop miss. So everybody with 100% gets a 0 in the new variable. So the new variable's name is happiness miss data, right? So that means, are they missing data for the 5-item happiness scale? So if they have a 1.0 in the happiness prop miss, that's 100%, then they're getting a 0 for the new variable, meaning no. So no, they are not missing data. So anybody with less than a 1.0, such as ID2, who has a 0.80, they've gotten 80% of responses. They're getting a 1, which means yes. Yes, they are missing data. So through these two variables, we've now answered the question, what's the proportion of missing/valid responses per study participant? And now with the second one, we could answer through the yes/no variable, what's the percentage of study participants that have missing or complete data? So in other words, if we do a frequency on the happiness miss data, this is what it looks like. Okay, so we can see here, right, the no means not missing data, right? There's 95 study participants that do not have missing data, right? And then 10 under yes missing data. Yes, there are 10 study participants that have some missing data. And those are the ones that go from the 80%, 60%, and 40% missing data under the other variable. Okay, so we've defined the missing data, and we figured out how to indicate how much data are missing in a few ways. So now we have to identify the patterns of missing data. Now, luckily, there are only 3 patterns which are commonly examined. Okay, so the first pattern is missing completely at random, MCAR. So that's the one that presents the least amount of challenge. Then there's missing at random, right? And you can imagine that's the middle amount of challenge, MAR. And then lastly, the one that presents the most level of challenge is not missing at random, NMAR. Okay, so let's define each of those and give an example of what they are. So missing completely at random means there's no patterns in the missing data. And that's what you want, right? Because if there's patterns to the missing data, that suggests there's some sort of bias to the missing data, as in some people are more likely than other people to provide valid responses or provide missing data. Now, for purposes of our missing completely at random, we would say missing values are not related to any other variable in the study, right? For example, having missing data might not be related to education level. So people at different levels of education, high school, college, and graduate school, might be just as likely as the other category to have or not have missing data. So that means there's no pattern to it, right? So how can we identify, right, if there's a pattern to the missingness, right? So we haven't done bivariate analysis officially, so we're going to have a little preview here. But essentially, you would take our variable, happiness miss data, like are you missing data, yes or no, and we could do a bivariate analysis, a one-on-one analysis with each of the other study variables. For example, we might do a chi-square where you can see the top center columns is the study participant missing data, yes, no, and the columns down the side have education level, high school, college, and graduate school. So what that's going to tell us is if there's any difference in who does and doesn't have missing data by these different categories of education. So the highlighted columns are what we want to pay attention to. So under is the study participant missing data in the top box. The column for yes is highlighted. So what that's telling us is the percentage within each category of education that has missing data, right? Or how much of the data, how many of the people in each category have missing data. So for example, for educational level high school, the first line, we see 9.4%, which is 3 people. So 9.4% of those with a high school education, did not provide data. Then C, college, 2, which is 6.9% of study participants with a college level education, did not provide data. And finally, graduate school, 5, which is 11.4% of people with a graduate school education, did not provide data. Right? So it's all pretty comparable, right? The numbers aren't radically different, but we need to see the level of significance to know if it's significantly different. So that's the last column in the bottom box where it says ASYMP SIG two-sided. That's the significance. Remember, 0.05 or below is significant, and this is way above 0.05. So what we've identified here is there's no statistically significant difference among the people that did and did not have missing data by levels of education. So the results of the analysis of bias regarding these data values may be expressed in a single sentence, right? So this is our check of missing data sentence, right, for a manuscript or report. An analysis was performed to assess bias related to missing data that indicated evidencing missing data was not significantly related to demographic or any other study variables, right? And in other words, it's missing completely at random as far as we can see. Now also keep in mind that we could define our yes-no categories not just as having missing data yes-no, but suppose we excluded people from the analysis because they had so much missing data, like the people that had 40% and 60% missing data, right? So, or valid responses, and the rest was missing data. So suppose they were excluded from the analysis, we might do our bivariate analysis, right? That center column in the chi-square, it might read excluded from analysis due to missing data, yes, no, instead of missing data, yes, no, right? So we could do it a couple of ways if we choose. Now, missing at random. Now, the first thing you need to know is the name doesn't really fit the situation. So missing at random actually means there are identifiable patterns in the missing data. However, we can identify the variable that relates to the identified pattern, right? So the missing values may be related to another variable in the study, right? Such as our highest level of education. So let's go back to our chi-square, see what that would look like, right? So back to our bivariate analysis. So here we go, here's our chi-square, but this time we have a different story, right? So we could see the highest level of the education level, right? It's really the highest level of education, but we're just calling it education level, high school. As we go across to the highlighted yes, right, 0%. So 0% of study participants at the high school level education have missing data, right? The same with college, 0%. So nobody with a 4-year college level education has missing data. But when we get to graduate school, all 10 of the study participants with missing data are in that category. So of people with a high school and college level education, 0% provided missing data, but of graduate school level education, 22.7%, almost a quarter of them, did not provide valid responses. And then we see in the final column in the second box, the significance, it's way below 0.05, 0.000. So what we would say here, there's a bias, right, by education level, where people with the highest level of education are significantly more likely to have missing data values, right? So when missing values are related to another variable in the study, such as a higher education, right, the bias related to it should be reported, right? So in the methods, we should say something like, those with a graduate school level education are more likely to evidence missing data values and may be underrepresented in the study. Something to that effect. We may also choose to include the variable reflecting bias, like education, in the final analysis, or do like the regression model, or take some measure to incorporate that bias in our analysis. Now the last one, not missing at random, the NMAR, right? Also called non-ignorable response, right? That means there's a problem and you have to pay a lot of attention to it, right? It indicates the pattern of missingness is related to the variable with the missing values. So it not only has consequences, it's also sort of confusing. Now, what exactly does that mean? Okay, for example, suppose we had a sample and it was racially diverse, and we knew it was racially diverse by recruitment and things of that nature, right? Well, suppose after the data were gathered, certain racial categories were not reported by study participants, right? And there was a bunch of missing data points. Well, what we might assume is that those racial categories were present, but chose not to report who belonged to what racial category, right? So it's very largely conceptual and hard to treat because we know something's missing, but it's hard to estimate what's missing, right? Because we know what should be there, but since there's a bunch of missing values and the things we know should be there aren't there, we know that the things are NMAR. Okay, now, how are missing data treated? And there's a variety of ways you can treat missing data. But the most useful to start is to put yourself in the situation of the analyst with the missing data, right? So if you're using SPSS, if you have a missing data point, it won't include the case in analysis. So you need something to enter in the cell, and of course something valid, right? So what can you do? Now, some people do complete case analysis. That means anybody with missing data is excluded from the analysis, so they don't have to put up with the missing data points. They don't have to account for them. But this is largely flawed because people who provide complete data tend to be fundamentally different than people who have some missing data or a lot of missing data. So if people have missing data and you exclude them from analysis, you've biased your sample. Maybe the people that provide complete data are detail-oriented, right? Well, now your sample is biased toward being people that are very detail-oriented, and all the people that are less than very detail-oriented are not included, and that affects your ability to generalize your findings to the entire study population. So what can we do? Right? Now, income is one of the items that most often has missing data values, right? Now, we should start off by saying the people that are most likely not to report their income are people that have very low incomes or very high incomes, right? So in that subset, that's what it looks like, right? Now, a common treatment, right, for income when it's missing is mean imputation. That means you look at all the people that did provide data, right? You take the mean of their responses, their mean income, and you put that in the empty cell for the people that did not report their income. Now, this is very risky, and it's really important to understand why. So say we have 14 study participants. Now, we're going to have two scenarios. Let's say these are their real incomes and these are their real happiness scores. Now, we're going to assume in a moment that we don't actually have all these values, right? So let's say that these are the actual scores, okay, for 14 people. Now, let's assess. We could see for IDs 1 through 8, the mean income is $50,000 and the happiness score is 3.5. So that tends to be in the middle of the happiness score. Remember, the entire continuum is 1 to 5. So they're, in the middle of happy and not happy. Now, IDs 9 through 11, they have a low income of $30,000, the 3. And their happiness score is 1.0, which is at the bottom of the happiness scale. And the last 3, 12 through 14, have a high income of $70,000, and their happiness score is 5.0. So you can see we have a range here, where the middle incomes are related to middle happiness, the low incomes are related to low happiness, and the high income is related to high happiness. So let's assume this is the actual situation. If we put it in a frequencies table, we have 8 study participants with a mean income of $50,000 with a mean happiness score of 3.5, 3 study participants with a mean income of $30,000 with a mean happiness score of 1.0, and 3 study participants with a mean income of $70,000 with a mean happiness score of 5.0. Now, as I said, the people most likely not to report their level of income are the very high or very low incomes, right? So let's assume IDs 9 through 14 actually did that. They did not report their income, right? And those are the extreme highs and lows. But say we still have their happiness scores. So you see for 9 through 14, we still have the happiness scores of 1 through 5. We just no longer know their income. It's missing data. Normally we wouldn't know what it would be. So suppose we took the average income of IDs 1 through 8, which would be $50,000, and we substituted those incomes for IDs 9 through 14. So now everybody has $50,000 income. So what would that look like? So now, if we look at our frequencies tables, we have 6 study participants again, with a mean income of $50,000 and a happiness score of 3.5. But now we also have 3 participants, right, that would have been the low income, but now they also have a mean income of $50,000 and a happiness score of 1.0. And the final one, 3 study participants that were formerly the high incomes, also have a mean income of $50,000 and a score of 5.0. So effectively what we've done by imputing the mean, or by substituting the means, is we've made it look like happiness, right, is the same for people with middle, low, and high incomes, because we couldn't identify those groups. So now it just looks like everybody is just as happy as everybody else, regardless of their income level. Right? So due to the choice to impute the means to account for the missing data, income is now distorted. Right? So happiness is now equally related to low, average, and high income levels. Right? So you need to be careful. Sometimes when you're reading a report, you need to wonder, right, if there were missing data reported and it was not reported how it was addressed, a researcher may be imputing means and not reporting it. So this may be going on, and it's important to realize it. So estimating a missing value for income, obviously, is a complex process. Here, a more advanced method of estimation, such as we mentioned, multiple imputation, right, might be considered, right, called MI. Now, if you want to do that, we have a free newsletter on the Stats Whisperer site that'll walk you through how to implement multiple imputation, right? Because it's very inconvenient when you have a missing income value and then you can't figure out a way to estimate it. So you can see that newsletter. What MI does is it compares the profile of the study participant with other study participants' profiles, and it looks at their income and their characteristics, and then it tries to estimate what the missing income value would be for the study participant with the missing value, right? It makes a best guess. And as you might imagine, guess is not my favorite word, right, for this, right? So it makes a best guess, but it's still a guess. So you have to look at your ideology here, right? So some people like to work with, the data that the study participants provided, right? And some people don't mind estimated values. So that's one of the things you'll need to decide ideologically for yourself, right? So other missing data might be dealt with less invasive methods, as in without guessing. For example, a missing value can be addressed by using the mean of valid responses, right? So that's not imputing the mean, right? It's the mean of value. So you'll see on the 5-item happiness scale on page 170 of the textbook, this is illustrated. And what that means is this, right? Suppose we have our feel glad again, and that has our missing data point, right? Well, we could take the mean score, right? The mean score of the valid items that are reported, right? And that would be sort of a trade-off. Specifically, it would be a trade-off because we would get a final value for the 5-item happiness scale, right? So for ID2, we're taking the mean score for feel happy through feel strong, the 4 items, which comes out to 2.0. So since you're taking the mean, it's on the same 1 to 5 scale level as the other IDs, right? So all of them are going to be between 1 and 5. The only trade-off is ID2 isn't going to have the dimension of feel glad in that composite score. So the composite scores are comparable, which is what we want. It's just that one dimension for feel glad won't be represented in ID2. However, the good part about this is you're getting a composite score that is based upon actual study participant data, and nothing's been imputed. Okay, so that is missing data. Now you should know these checks of data assumption, like I said before, these are the most involved and often the most complex part of a quantitative research study. And many times they're skipped over completely. But like I said, what's the value of a study if we haven't made all these necessary checks and the findings are inaccurate, right? So we've done missing data, right? So we have one thing left, which is our measurement tools. Now, measurement tools, traditionally, reliability and validity are assessed for each tool. And there's several types of reliability estimates, right? Inter-rater, test-retest, right? Inter-method. Now, there's also internal consistency reliability. This is the most reported, right? So that's what we'll talk about here today. So the measure of internal consistency asks, is a single construct being measured with a set of items, right? If a single construct is measured, the items will be correlated in a pattern, right? So our 5-item happiness scale, this would apply. So look at it this way. If somebody was just completing the 5-item happiness scale, you would expect them to answer in a certain pattern, right? If it was really measuring happiness. For example, this study participant, for happy, they said 5. they strongly agreed that they felt happy in the last 7 days. So the next item said, well, if they've been feeling happy in the last 7 days, right, they've probably not been feeling sad. So the happy is 5, then the sad is 1. So if there's happy present, we would expect sad not to be present. So the happy would be 5, the sad would be 1. Now the other positive emotions, good, strong, and glad, right, they should be present along with happy because they're positive emotions. So all the positive emotions are to the right, indicating their presence, and the negative emotion sad is to the left, indicating it hasn't been there. Right? Now you could also have the opposite, right? So this person for sad, they circled 5. So they're indicating that in the last 7 days, they really felt sad. Now the other items also correlate, right, negatively, right? Remember, negative is one goes up, the others go down. So as sad goes up, all the positive items are negatively correlated. They all go down together, right? So sad is present and the positive emotions are not present. Now when this happens, we assume that the construct of happy, right, is being measured. Now what if you had something like this? This looks like a no correlated item pattern, right? So this person said, happy 5, they've been really happy in the last 7 days, but then they've also indicated in the last 7 days they've been like extremely sad too. And then they felt good, they indicated they didn't feel good, they neither agree or disagree on strong, but they have felt glad. So this looks like a pattern that is not indicating the presence of happiness, because it looks like it's indicating mixed reports, right? So that's going to have low internal consistency when it's mixed like this. When the correlated patterns come up, that's going to have high internal consistency because it seems like a single construct is being measured. Now, the intercorrelations reflect the presence or lack of internal consistency, right? So the internal consistency is measured, right? Internal consistency reliability, actually, is measured via the Cronbach's alpha, and that goes from 0 to 1, right? And the standard is the Cronbach's alpha must be 0.7 or greater for a scale to be reliable. Now 0.7 is even pretty weak, so 0.8 or 0.90 is even better. Now to examine internal consistency in SPSS is rather simple. Let's look at that really fast. Okay, so we go to SPSS, analyze, right, scale, reliability analysis, and we just put the items for our 5-item scale over to the right, over here. Right, now remember, we want to put in feel, said, reversed, right? You have to be careful not to put in the original. Then under statistics, click that, and always click scale if item deleted, continue, and then we would paste it, right? We could also click OK, which we'll do here. Right, so this is what it's saying. So valid 100. So the Cronbach's alpha here is 0.868, which rounded up is 0.87 for our 5 items. So the internal consistency is very good, right? Way above 0.7. And then the scale if item deleted, that tells you what the internal consistency would be if you got rid of this item, right? It looks like none of them are above 0.868. So it looks like they're all contributing to the internal consistency, right? But if this was like 0.60 and then this said 0.80, that would mean deleting that would bring it up to 0.80. Okay, so there's the path, right? So if the Cronbach's alpha is less than 0.70, we should consider removing the items, right, from the from the scale is with the scale if item deleted function. And then note, right, if we put in the original SAD instead of the reversed, that might drag down the Chromax alpha because it's correlated the wrong way. So always check that if you have a low Chromax alpha. Okay, so there we go. Measurement tools are done. So we've made all 4 checks of data integrity. So again, our broken record, checks of data integrity are necessary to find findings credible, right? One mischeck could ruin our findings. So the quality and future of statistical research hinges on appropriate checks of data integrity. So next class, we're going to review drafting a research proposal, which is a marketable skill. So we'll look forward to that. Okay, thank you for watching and have a good day.